Welcome back, Leo Lions. This is Mrs. Morgan with today's lesson over scatter plots. And then we're going to talk a little bit about the types of association or correlations that we see in scatter plots. And then we're also going to talk about some vocabulary with outliers and clustering in scatter plots. So first of all, what in the world is a scatter plot? We're starting our data and statistics bundle. So scatter plots are graphs that use points to display numerical data. So a lot of times data, statistics, we are surveying people, we are collecting information, and then we use different graphs, pictures to display that data so that it's a little easier to interpret and understand. So these scatter plots have to deal with numbers, meaning numerical data. And then there also has to be two variables, two things that we are looking at. So we call this bivariate, bi meaning two. So this is bivariate data. So there'd be two things that we are looking at having to do with numbers, and then we're comparing those on the graph. So maybe the height that you are, and the other one maybe the age that you are. So as you grow up, your height is getting bigger, and then there gets to a certain point where, well, your height isn't going to change anymore. So that's what we would put on the scatter plot. Scatter plots can help determine if one variable has an effect on the other. So basically what we're looking for are patterns, we call them trends, we call them correlations, or associations. All of those words mean the exact same thing. So we're trying to look for a pattern between these two variables. So the associations or correlations you may see, or trends, patterns, there's three types. We have positive, negative, and then no association, meaning they don't have an effect on each other. So positive association means two variables have positive association when they both move together. And what that means is that both of them have to go in the same direction. For example, as one variable increases, then the other variable also has to increase. So they both have to go the same direction. Now on the graph, it would look something like this, and we'll eventually draw trend lines, but what you can see is it's a positive, it is going uphill, positive slope. So your x-axis, as the x-axis is increasing up, the y-axis is also increasing up. So that's an example of positive association. Negative association are two variables when they move in opposite directions. So for example, as one of the variable increases, well then it'd go in the other direction, so the other variable would decrease. So for example, it looks like this over here. So your x-axis is always going to be increasing. But in this case, your y-axis, what's happening is everything is decreasing, and it has a downward slope on the graph. And then last example is no association. So two variables that have no association when there's no effect on each other. And it looks like this on the graph. We can't see a pattern with those points. So we can also look at associations just based off of the scenario. We don't actually have the picture. So the hour a person studies, so think about as the number of hours that you spend studying for a test. As you increase the number of hours you study, what happens to the number of states that you visit? Well, those really don't have anything to do with each other. If you're studying for a test, it's not going to change how many states that you are visiting. So I'm actually going to say no association. Okay, next one. The hours a person studies, so here again, same thing. So the number of hours, as that increases, what happens then to the grade on their exam? Well, hopefully, if you're increasing the amount you're studying and you study quite a bit, well, hopefully then the grade also increases and goes up. So this would be an example of a positive association. And then last example we have here. So the hours a person studies, so again, same thing. So the number of hours, the more you study, and the hours they spend watching TV. Well, think about it. If you're spending hours studying, Well, hopefully you're not watching TV, so that would mean the hours that you're spending watching TV is going down. It's less. So those are going in opposite directions. As one increases, the other one decreases. So this would be an example of a negative association. Okay? Now, if a straight line can be drawn to follow the overall trend line of a scatter plot, so straight line, then we call this a linear association. Linear has the word line in it, so linear means that it's going to form a straight line. So all those examples we looked at up above, they all form straight lines except for that no association. So if the points of the data are close together, then the association is strong. That means the correlation between the two variables is very strong. It's very likely that as one increases, the other one increases. But if the data points are widely spread, so they're not as close, they're more spread out, well then that's what we call a weak association. So we're going to name basically three things here. We're going to label each type of association, so positive, negative, or no. We're going to write down the strength, so is it strong or weak? And then we're also going to decide if it is linear or not. So first example, we can see it is going uphill. So this is an example of a positive association. All of these, the points are pretty strong. They're pretty close together. They're all pretty close to that line. So I'm going to say this is a strong association. And on the graph, it does form a straight line, so that is linear as well. Next one, it is uphill as well. So this one, again, is a positive association. However, these points are a little more spread out. They're not as close as the last one. So this would be a little weaker than the first one. And again, it is forming a straight line, so it's linear. Next one, it is going uphill, but notice there's kind of a curve to it. So this is a positive association. I think it's pretty strong. Those points are all pretty close to that line that I drew, so this is a strong association. And then we would say this is non-linear since it doesn't form a straight line. And at this point, we've done a few together, so pause the video and see if you could identify these last three examples. Number 4, it is going downhill for our slope, so this would be a negative association. It is pretty strong, and it does form a straight line, so it's linear. Next one, again, it is going downhill, but it does not form a straight line. Again, I would say it is pretty strong. I think that all the points are decently close together here. So I would say this is strong and this is non-linear. And then last example, there's just points all over the place. So this is an example of a no association, which means that it's not strong or weak, and it also doesn't have a linear relationship. So there are those examples. That's how we look at a scatter plot and decide the pattern, what's happening between those two variables that are listed on the scatter plot. So next example, we're actually going to construct a scatter plot. So when we do this, we want to make sure that all of our data points will fit on this graph. Notice that nothing is labeled on the x and y axis. So let's first figure out what's going on. Jared's basketball team stood at various distances from the basketball goal and counted the number of baskets they were able to make in 30 seconds. The distance each person stood from the goal and then the number of baskets made are shown in the table. So the two variables we're looking at is the distance each person stood from the goal and then the number of baskets that are made. So on the x-axis, we're going to put the distance from the goal. We always want to label so we know what is going on in our graph. And then on our y-axis, we would say the number of baskets made. And it's kind of hard to write sideways here and still be able to read it. Number of baskets made. Now, like I said, we want to make sure that we use as much of this graph as possible. So our x-axis, we want to figure out what's the biggest distance that we're standing away. So we have a 25, 27, looks like 28 is the biggest. So I'm going to count the number of lines that are here. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So perfect. If we double it, then it would give us 28. So what I am going to do is always start with 0 when you number, and each of these lines are going to go by 2s. And if you didn't go by 2s, we would only be using about half of this graph. So that's why it's important to count and try to use as much space on this graph as possible. And there we do have 28 on there. That's the furthest distance. Now, number of baskets made, the most that we have on here is 14. So we know we have to go up to 14, and it's going to be the same size. There were 14 lines. So now I am labeling the Y, but I'm going by 1s. And if you ever change the intervals on a graph, you have to make sure you label them like we are doing. And then there we can fit 14 baskets on there. So in the end, we would graph all these. So 14 feet, I'm going to go to 14, and then 1, 2, 3, 4. Then we have 25 and 6. So I have to go directly in between 24 and 26. And then 1, 2, 3, 4, 5, 6. 27 and 7. And at this point, you could pause the video and plot all of your points and see if you could construct an accurate scatter plot. 15 and 11, so I have to go right in between 14 and 16. And 11 is way up here. And then we have 26, 6. And you can kind of see already that there's a group of points that are together there. 16 and 13. I know that one's 11 up here. So 13 will be up there. 15 and 12. And again, I see another group of points here. 26 and 8. Sixteen, 14. And way at the top, I forgot that I labeled it all the way to 14. So I was counting, and I guess I didn't have to. And then 28 and 5. So there are all of our points on our scatter plot. So what type of association do you see in the scatter plot? And then says list any observations in the space. So first of all, what I notice is there are basically two groups of points. We have a group here and we have a group here. So oftentimes I see students say, well, there's no association here. But notice that there's a big group here of no points at all. And think about what's going on in this problem. If you increase the distance from the basket, my assumption is, well, you're also going to make probably less baskets. So it looks like a group of kids probably stood together all about 14 to 16 feet away from the basket. And then here, this group of kids stood about 25 to 28 feet away. But notice nobody chose the distance in between here. But if they did choose those distances, well, what do you think would happen? My guess is that there would be other points in between here, but we just don't have those. So yes, it doesn't look like there's an association, but if we think about having those points there, well, there would be a negative association. And that also helps us when we think about, without even looking at the graph, like I said, if we increase the distance from the basket, well, the number of baskets you make are going to go down. So there's negative. We're going to list some observations here as the distance from the basket was increased. The number of baskets decreased. and I guess I'm going to say the number of baskets made. And you could also list some other observations that you see, talking about how there are kind of groups of points together and how maybe some guys did not choose distances in between there, and that's why there's some missing points there. So let's look at these true-false statements. So as the distance from the goal increases, so distance increases, the number of baskets made decreases. Well, that's exactly what we just wrote down. So that is a true statement. As the distance from the goal decreases, well, we know it has to go in the opposite direction, the number of baskets made increases. So I agree. If you're closer to the basket, well, the number of baskets you make are going to increase. So that's true as well. As the distance from the goal decreases, the number of baskets made decreases. Well, those are going in the same direction. Remember, if the two variables are going in the same direction, that's a positive association. And here, our scatter plot is definitely showing a negative association. So that last one is a false statement. Okay? Now, let's look at these last two definitions. A point that does not fit the overall pattern. So the overall pattern or association or trend, then those are what we call outliers. So, who was the outlier in the scatter plot above? Well, there is one point here that does not fit with the other points, so this point here is an outlier. And think about who was that point. Well, 14 feet, 4 baskets made, that was Jared. So who is the outlier? Jared was the outlier. He had similar distance to some of the other points. He just didn't make as many baskets as the others. So similar distance, but didn't make as many shots. And then last vocabulary word here are the clustering. So clustering occurs in a scatter plot when there are groups of points together. And why do you think clustering occurred in this scatter plot above? Well, we kind of talked about that. We talked about there are two groups of players that chose similar distances from the basket. So there we have an example. We were able to take the data that was collected from those guys choosing distances from a goal and then shooting baskets. We were able to take those data points. We created a scatter plot, and then we were able to look at what type of association was there. We saw an outlier, we saw clustering, so there's a lot of things that we can read and interpret from using scatter plots to organize certain data that we have collected. So there is our first lesson over scatter plots, and we'll take even a deeper look into using these scatter plots.